dear friends, welcome to GATE Academy Global. So before starting today's session, I would like to take the concurrence or the feedback regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we shall start our today's session. The agenda behind today's session is almost connected with the yesterday's session. In yesterday's session, I started the concept of Cartesian coordinate system and I just began with x, y, z. What does it mean by the x? What does it mean by the y? What does it mean by the z? And I was discussing about their limits. So the limits of the x, y and z were starting from minus infinity and were going towards plus infinity. And at the same time, when I proceed forward, I was discussing about the octant system. When we had the 2D coordinate system, so basically the complete structure could have been distributed in the 4 different ways in terms of their signs. Yes, the first quadrant, second quadrant, third quadrant as well as fourth quadrant. But once you have been dealing with the 3D coordinate system or 3D Cartesian coordinate system with the help of their different signs, positive or negative, basically the complete 3D space could have been distributed in the 8 different ways. 8 different ways. Yes, no? 8 different ways. So that is why the concept of the octant system have come into the picture. My dear friends, why the octant system is so important? Because in future, if you are from electrical, electronics or instrumentation, specifically when we deal with the boundary conditions related problem, and even in mechanical, when we discuss about the heat flow in thermal, we used to have the applications of the octant system. So anyways, I would not be going into the much details of the octant system, at least at this moment of time. At this moment of time, sir, tough concept, explain. My dear friend Bappi Singh, today really you are going to enjoy my session because you will actually understand what does it mean by the curl, what does it mean by divergence, what does it mean by the gradient. That is what I am saying. No, let me start from the very beginning. Now see what was happening 2 months back. We had the sort of time because the gate was on the way. That is why we were taking the each and everything into the very Hessian way. But now we had got the time and now we had to strengthen the each and individual concepts up to its depth. That is why I have started from the core of or the basics most of the Cartesian coordinate system and slowly we are building our concepts. Please Umesh sir ki network ki video again upload kar do. Yes, my dear friends. So the agenda is quite clear. That's nothing but the lecture 2. The student who have come across this series of video first time, let me tell a brief about this series. My dear friends, this would be the series over the engineering mathematics and I suppose to cover the 2 different kinds of the topics. At very beginning, in next 10 to 15 lectures, I would be focusing over the vector calculus. Once we are done with the vector calculus, we would be moving forward with the random variable, random process, probability distribution, probability density. And yes, yesterday we had the class of 1 hour, which was from 9 to 10 p.m. And from here onwards, we by default be having the class in between 9 to 10 p.m. So whether you get the notification or not, whether you get the post over our group or not, by default it is but understood, yes, the Sonal sir would have the class over the engineering mathematics and the schedule would be from 9 to 10 p.m. So approximately we will be having approximately hour of 1 in each day. Anyways, let me see the comments what we are having. Love from Guwahati sir. Thank you Bappi Singh. And definitely my dear Bappi, what is happening today? Today, once you'll see the different types of the vector quantities, so far you may not be able to know, sir, how the divergence is being performed and what is the physical significance of the divergence. But in today's lecture, definitely you will start smelling the concept of the divergence, curl as well as gradient. That is why I have started from very basics. Anyways, let me go ahead. Let me commit to the working board. Anyways, let me distribute into the 2 parts. Just a minute. How it's happening here? How it's happening? Anyways, let it aside. My dear friends, in today's lecture, I would be focusing over the 2 important factors. The first I would be focusing over, write it down. I would be focusing over differential length. I would be focusing over the differential length. And yes, differential length is very important once we deal with the line integration, specifically vector line integration. Anyways, what does it mean by the differential length? The name itself is self-explanatory. It is an infinitely small length. And now that infinitely small length can prevail in the direction of x-axis, can prevail in the direction of y-axis, can prevail in the direction of z-axis. So the differential length which prevails in the direction of x-axis, we call it d of x. Similarly, the differential length which prevails in the direction of y, we call it d of y, and similarly, the differential length which prevails in the direction of z, we call it d of z, d of z. So for the better understanding, what I would do, let me take a coordinate system. Anyways, let me do one thing. Let me restart the computer. Probably there is some malfunction is going on. No issue. So let me restart. So probably each and every problem would get sorted out. Wait a bit, because whatever I am writing over the digital board, no, automatically it is getting removed. So probably after restarting, each and every problem would get sorted out. Just a minute. Let me go into the working board. Just a minute. Yes. Yeah, everything is fine now. See what I was saying, the agenda behind today's video, I would be focusing over the remaining part of the Cartesian coordinate system, and to begin with, I would be starting with the differential length. I would be starting with the differential length. Yes, I would be starting with the differential length. My dear friends, as I have been discussing about the differential, that means the infinitely small length, that means I am discussing about an infinitely small length. In the direction of x, it could be dx, in the direction of y, it could be dy, in the direction of z, it would be dz. So let me do one thing, let me use the Cartesian coordinate system which we have used earlier, Yes, so here goes my z axis, here goes my positive y axis, and here comes my positive x axis vertically outside from this 2D plane. So now what I am going to do, let me draw a cube over here. Let me draw an infinitely small cube over here. Yes. So I have drawn a cube over here. This is the direction of my positive y axis. This is the direction of my positive x axis, and this is the direction of my positive z axis. And what it is? It's an infinitely small cube. For the time being, you can write differential volume. Yes. Now the differential volume have come into the picture because of few of the differential lengths. May I know what are they? The differential length, you can see very well, it's an infinitely small differential length is in the direction of x. Probably you may not be able to exactly understand, but yes, it's a vertically out. So you can see very well how many differential length we have in the direction of x. First we have this, second we have this, third we have this, fourth we have this. Yes, you can take the reference of any of them. Similarly, the differential length in the direction of z, the 4 number of differential length you have in the direction of z, that's nothing but the first one is this, second one is this, third one is this, and fourth one is this. And similarly, the 4 differential length you have in the direction of y, and that is nothing but dy, 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 and dy. So put together the 4 number of differential lengths you have in the direction of x, y, as well as z. You can take the reference of either of them. So what I am going to do over here, I am taking the reference of this differential length, I am going to take the reference of this differential length, and I am going to take the reference of this differential length. May I know what are they? So obviously you yourself would be able to visualize. Obviously, sir, it's an infinitely small length which has been prevailing towards the direction of y-axis. So it's gonna be utterly small, infinitely small length in the direction of y. Why don't we call it dy? And once the dy is done, definitely it is a differential length in the direction of x. Why don't we call it dx? And similarly, it's a differential length in the direction of z. So why don't we call it dz? So in future, whenever we discuss about the differential length, specifically in Cartesian coordinate system, we would be having the 3 differential lengths in the direction of x, y, and z. Why don't we write it somewhere here? So obviously in the direction of x, the differential length is simply going to be d of x. The d indicates differential. Similarly, in the direction of y, it's going to be simply dy. And in the direction of z, it's simply going to be dz. Yes. But most of the time in engineering mathematics, you would not be dealing with the differential length, you would be dealing with the differential displacement. Just I wanted to know from each one of you what's the basic difference between differential length and differential displacement. If you guys are well aware with the difference between length and displacement, just write over the live chat. I wanted to know how many of us exactly know the difference between the length as well as the displacement. But here I am not talking about the length, I am not talking about just displacement, I am talking about the differential displacement. And yes, the concept of differential displacement is utterly important in engineering mathematics. Either you are from any of the branch, electrical, electronics, instrumentation, civil, chemical, any of them. Sir, please tell about the timing of the lecture and schedule. Anurag Patil, I have already communicated, probably you have joined my session bit late. From today onwards, I would be having the daily basis classes, and the class would be held in between 9 to 10. That means precisely or dot at 9 p.m. we would start our lecture, and the lecture would have the span of 1 hour. So probably at 10 p.m. we'll bind up. Yes. Agreed, no? Agreed. Now I would be focusing over the differential displacement. Again, differential, that means infinitely small. Displacement, that means the distance along with the vector or along with the direction. Displacement. Now, many of the times the student used to have one confuser, sir. What was the problem with the differential length such that I need to go to the differential displacement? Yes, we have certain problem which cannot be addressed by the differential length. For the time being, if I take an example, this example can be taken for the mechanical, civil, electrical, electronics, for all of these streams. Yes. What I am saying, try to understand in this way. If force vector is coming towards you, the force vector is coming towards you, or you can say the force vector is in direction of minus ay cap. Now, yes, this direction is the direction of the positive y axis. That means if the wave or if the vector quantity moves in this direction, definitely the direction would be plus ay cap. For the time being, I have got a force vector which is moving against the positive y axis. What does that mean of it? That means you have got a force which is moving in the direction of minus ay cap. Yes. What I am saying now, now if you are displacing from its place, or if you are moving from its place, definitely you are going to travel a certain path. But now that path traveled is being in which direction is going to decide whether the work has been done or not, whether the work has been done by you towards the system, or whether the system has done work on you. If I'll take an example, the force is coming towards me, and if I am struggling and going towards or against the force, may I know the work has been done by the system or work has been done by me towards the system? Obviously, the work has been done by me towards the system. What I am saying, the force vector is coming towards me, and against the force vector I am moving towards the force vector or against the force vector. So obviously, the work has been done by me. Now, if I take another case, the force vector is again in this direction, and if I am moving back, or I can say my movement has been in the direction of force vector, What does that mean of it? That means the system has done work on me. Now, if I take another case, the force is in direction of this direction, and if I am moving towards you, or going back, what does that mean of it? The force is in this direction and the movement has been in this direction. That means the angle between the movement as well as force is 90 degree. Neither the system is doing work nor you are doing the work over the system. What does that mean of it? Although you are traveling a certain differential length, but even the direction of that length matters a lot. If a differential length has been traveled in this direction, that means you have done work over the system. If the differential length has been traveled in this direction, that means the system has done work on you. And similarly, if you move towards this side, differentially, there is no work done at all. What does that mean of it? Could you figure it out? What exactly sir wanted to communicate? The sir wanted to communicate differentially, if you traveled from one point to another point, even the direction also makes sense, specifically in vector field, because sometime you might be working, sometime the system might be working on you, sometime there would not be any work done. Agreed? Why the differential displacement is important? So I think we should start from its basic definition. The differential displacement is the extension of the differential length along with its vector quantity. So write down the differential displacement is differential length, that means infinitely small length you had to travel, differential length, but the vector direction would be added along with your differential length, Could you understand what I am saying? So now one basic difference you will get, it would be a differential length with the direction. So I would be just marking it dl vector. And now you can have the differential length in the direction of x, that's a dx, obviously in the direction of x, so the unit vector in the direction of x, that would be the ax cap would get attached with the dx. Now even it could have been in the direction of y, so it could be dy ay cap, and even the differential length could have been traveled in the direction of z axis, that is nothing but the dz az cap. Agreed? So I would recommend or suggest to each one of you, better to by heart this formula of the differential displacement, because once in future I would be taking plenty amount of the problem from the vector line integration, this differential displacement or the structure of the differential displacement has to be used again and again. So you can mark this out. Now just for the better understanding, let me take the three different types of examples. The first example, let's take the force vector is coming from right to left. In first example, if I wanted to travel against the force vector, let's take I have got a mass and the mass is traveling against the force vector. That means the differential length has been traveled by this mass. It has been started from here and it has moved till this point, and yes, the direction is also known. May I know who is working? Whether you are working over the system or the system is working on you. Obviously you are working on the system. That means the work has been done on the system. Work has been done on the system. Yes. And now if you do not know its direction, if you know only and only differential length, you do not know the direction, then you would not be able to figure it out whether the work has been done over the system or the system has done work on you. Not only that, if I take the second condition, now again the differential length has been traveled, you have started from this point and you have moved till this point, and the direction is clearly known to me. May I know the work has been done by you or whether the system has worked on you? So obviously the system has worked on you. Yes, system has worked on you. Now if I take the third case, is like the mass is moving in perpendicular to the direction of force vector. So obviously there would not be any work done, neither the system is doing work nor the work has been done by your side. No work. Yes. So that is what I am saying. The extension of the differential length, that's nothing but the differential displacement is more important in compare with the differential length, because many of the times the movement should also possess the direction to execute the actual work done. Until and unless the actual direction is not known, you may not be able to know whether the work has been done or not, whether the work has been done by your side or whether the work has been done by your system. For the time being, if you are saying differentially 1 meter displacement has been taken place. Now if it takes place towards this direction, the work would be done by your side towards the system. If 1 meter displacement has been done in this direction, that means the work has been done by the system on you. And similarly, if the displacement of the 1 meter has been done in this direction, that means there is no work done as such. Agreed? No? If any doubt you guys are having, you can just ask over the live chat. So at least I'll get to know if any sort of doubt you guys are having, definitely I can take now. So I would request to each one of you, you need not to use the live chat again and again. So in between, I would be taking pause for maybe 2 or 3 times. So any sort of doubt you guys are having, no, you can put the doubt at that during of time so that I can address that. Sir, was EC 2021 tougher than 2018? I cannot exactly say. 2018 was a very, very tough examination. Yes, it was a very, very tough paper. Anyways, we'll move forward. We will move forward. Now, I am going to use a few of the nomenclatures and we'll try to draw its field. Write down. Draw the vector field and analyze the divergence and curl. And now it's gonna be a utterly important topic. So I would expect from each one of you, nobody should linger here and there. Just focus what I am going to speak for the next 20 minutes, because that 20 minutes are going to be utterly important 20 minutes, because you will actually know the crux of the divergence as well as curl. Because many of the times I have seen, once I will say you know divergence, you know curl, the student would say, sir, yes, we know how to calculate the divergence, how to calculate the curve, but physical significance of the divergence and curl, sir, exactly I do not know. So that is what I am saying. I have designed the few number of problems, and with the help of few number of problems, I would try to visualize what does actual mean of the divergence and what does actual mean of the curl. Yes, let me take first question. I am going to draw few of the vector field. Let's start with the first vector field, which has to be drawn over the Cartesian coordinate system. Many of the times the vector, try to understand, the A is obviously a physical quantity. The vector has been written over the A, that means it's a vector quantity, and now within the bracket x, y, z has been written, that means this vector quantity is the function of x, y, z, and this 3 number is possessed in Cartesian coordinate system. So easily you would be able to understand it is a vector quantity in Cartesian coordinate system. Yes. Now if I take an example of, let's take a y cap. Yes, let me draw over the Cartesian coordinate system. Here goes my x-axis, here goes my y-axis, and here goes my z-axis. May I know what does that mean by the ay cap? If we'll talk about its magnitude, obviously how the magnitude has to be taken out, it's simply gonna be 1. Anyways, we will be talking about the magnitude of the any vector quantity in future. And if we'll talk about its direction, how the direction is being calculated, we divide the magnitude with its vector. The magnitude is simply 1. So ay cap getting divided with 1, that means the direction would be in the direction of plus ay cap. Agreed what I am saying? So if we'll talk about its magnitude, the magnitude is simply 1. This vector quantity has the magnitude is equals to 1, and similarly the direction all the way, it is always in the direction of plus ay cap. Yes. Now what I did to understand the magnitude of ay cap, anyways we had to draw the ay cap over the 3D coordinate system. No? So what I have done, I have taken the arrows. The length of the arrows are being decided by its magnitude. If the magnitude of the vector field increases, the length of the arrow has to be increased, and similarly the direction of the arrow is indicating the direction of the vector field. So may I know what about the length of the each and individual vector field? Obviously it has to be unity, because the magnitude has got stuck on 1. Not only that, even the direction would always be in the direction of plus ay cap. So if you really wanted to know how the plus ay cap would look like, so for all values of x, y and z, the direction would always be in the direction of plus ay cap. That's the first thing. So obviously you can see the arrow is heading towards the positive y-axis. Not only that, even the chord length has not changed. The chord length has been fixed to 1 meter or 1. because the magnitude remained constant throughout the region of Cartesian coordinate system. That means even the value of x, y, z is changing, is still the magnitude is same. Magnitude is same. Yes. Now I would like to ask one thing from each one of you. I would like to ask from each one of you, tell me what would be the divergence at this point or at this point or at this point. So the student who know how mathematically we calculate the divergence, probably the divergence of ay cap they can calculate easily. So may I know mathematically what would be the worth of the divergence of the ay cap? It is a vector quantity. Obviously the divergence can be applied over a vector quantity, and once you get its result, tell me how much result we are getting from exactly ay cap. I wanted to know from each one of you. I wanted to know from each one of you. What would be the divergence of ay cap? What would be the divergence of ay cap? Anyways, I want the reply at least from 2 guys over the live chat, because we would be entering it to the very important part of the divergence. Tell me what would be the divergence of ay cap? Mathematically speaking, divergence of ay cap, it can be easily calculated. How do we calculate this? It used to be a scalar quantity, which is nothing but the partial differentiation of the component of a vector in the direction of x, which is ax, dou of dou y, a of y, similarly dou of dou z, a of z. Yes, and now you can see very well, here you have got only one component, and that too in the direction of ay cap, and the magnitude of the component in the direction of ay cap is simply 1, and the remaining component in the direction of ax cap as well as az cap is 0. Neeraj Singh Bhist, something mistake you are going to do, my dear friends. See what I am saying, if you really wanted to know, this vector quantity could have been written in terms of ax cap, ay cap, az cap. So now you can compare this vector quantity with the standard vector quantity, and you can get the weightage of ax, ay and az. You can see very well. See, the component of ax cap is absent. What does that mean of it? That means the value of ax is 0. Similarly, the component of ay cap is present over here, and if I compare with the ay cap, we get to know the value of ay is simply 1, and we compare with the az cap, we get to know there is the absence of az cap. That means the multiplier factor az is simply 0. Az is simply 0. So what I am going to do over here, I am going to just feed those values out over here, right? So here the value of ax which we are getting is simply gonna be 0, yes, and here it's simply gonna be 1, no, and here it's simply gonna be 0. How much the value is? The value is simply 0. Value is simply 0. Anyways, once you'll go into the detailed study of the divergence, no, then you'll get to know the divergence talks about the sourciness or sinkiness of the field. Which field? Vector field. I repeat, divergence talks about the sourciness or the sinkiness of the field. May I know at this point whether the field is getting sourced or whether it is getting synced? What does it mean by the sourced or synced? My dear friends, see, the magnitude of 1 is going inside this point, and the same magnitude of 1 is coming out from this point. What does it mean of it? That means the worth of or the magnitude of the vector field which have gone inside, the same worth or the same magnitude of the field has been come out. So may I know how was the behavior of the field over this point? Whether it was getting synced, whether it was getting sourced, or whether neither it was getting sourced, neither it was getting synced. No, my dear friends, neither it was getting sourced, neither it was getting synced. Why? Because the amount of magnitude have come into this point, the same has been left out. The same has been left out. Not only here, you can take the reference of any of the point over the 3D space, any of the point. You can see the magnitude. What's the magnitude over here? The magnitude is 1. What's the magnitude over here? Magnitude is 1. What's the magnitude over here? It's a 1. What's the magnitude over here? It's a 1. What does that mean of it? That means at least at any moment of point over the 3D space, if you see how much the magnitude of the field has been sink in and how much the magnitude of the vector field has been sourced out, you'll see they have been same. They have been same. What does it mean of it? Neither it is sourcing nor it's sinking. If you talk about the sourciness, what does that mean of it? If a field is sourcing, that means the two field lines are coming in or the magnitude of field which is coming in is rare, whereas the magnitude of the magnetic field or the field which is coming out is stronger. Now you can say that yes, at this particular zone it is getting sourced, it is getting sourced. Similarly, if I take another situation where the 3 flux line is coming in and only 2 flux line is going out, may I know what is the situation over here? The situation is just reversed, and here it is sinking. Why? Because out of 3 number of arrows which have come in, only 2 arrows have gone out. 2 arrows have gone out. Agreed? So I would like to ask from each one of you, at each and individual moment of point, field is neither sourcing nor sinking. The amount of magnitude which have come in, the same amount of magnitude is leaving from that point. What does it mean of it? That means AY cap would be divergence free vector, and you can see very well mathematically when I calculated the divergence of the vector field A vector, the value was simply 0. The value was simply 0. Agreed? Agreed? So each one of us should have the clear-cut idea. Now I would like to ask one more important thing. What about the curling at this point? Now if I would like to calculate the curl of the vector A vector which has been written as AY cap, may I know what would be the value of this? What would be the value of this? Anyways, the student who are live on the live chat, I would at least expect whenever I come across a certain important factors, you should calculate over your copy and you try to give the answer over the live chat. Then only there would be the two-way communication and I would be able to understand how far you are able to understand my concepts. May I know what would be the curl of the vector quantity A vector which has been taken as AY cap precisely? Tell me what's the worth of it. How we calculate curl? Anyways, the curl would be a separate topic, but still for the better connectivity with the Cartesian coordinate system, I need to take few 1 or 2 number of problems. So if we calculate the curl of AY cap, so simply it's gonna be dou of dou x, dou of dou y, dou of dou z. Yes, and here the component of Ax is simply 0, the component of Ay is 1, and the component of Az is simply 0. And now you can see by yourself what is happening over here. Once you will start differentiating, you can see very well each and individual factors or the terms, they are not containing either x, y or z. What does that mean of it? That means in future once they get differentiated with either of the factor x, y, z, end of the day they are going to result null. That means the result is simply going to be a null vector. Anyways, if we'll briefly try to understand what the curl of any certain vector talks about. The curl of a certain vector talks about the curliness of that field, rotation of that field. How mathematically we can determine how much source. Now we will be talking about that also. Yes. So what I am saying, whenever you calculate the curl of the field, you talks about the rotational behavior of the field. Tell me, if I have kept a point somewhere here, whether this point is getting any rotational force or not. You try to experience by yourself. You place yourself somewhere here and try to experience whether you are getting any rotational force along this point or not. My dear friend, just take an example. Take an example. We have got the train tracks. The one track is somewhere here. The another track is somewhere here. If parallelly the two trains are moving with the same speed, but I am saying if parallelly two trains are moving with the same speed, and now if you have been placed in between, the one track is moving from here, the another train is moving from here, may I know whether you would be getting any rotational force or not? No, you won't get. Even you yourself would be able to experience this. You try to experience. Yes sir, we have got the two tracks. The one track have the train which is moving with the speed of x, the another train is moving the same direction with the speed of x. Would you get any rotational force? No. But if their speeds are different, my dear friends, if the speed of this train is higher and the speed of this train is slower, definitely I would be getting a curling force or rotational force. Not only that, even one train is moving in this direction and another train is moving in this direction, then also I would be getting a curling force, or I would be getting a rotational force. I would like to ask from each one of you, practically, whether you are able to understand that there would not be any rotational force across this point, whether yes or no. Tell me. No, because both have got the same magnitude. That means this vector quantity, this point would not have any rotational force, and if it does not carry any of the rotational force, definitely in future, if you will calculate the curl of this vector quantity, the curl of the vector quantity has to be null vector. Could you understand what I wanted to say? Yes. Agreed, no? Now let me take few more number of examples, and with the help of those examples, I would try to explain the things in even better way. See what is happening over here. Now I have changed my vector a bit. Again, the vector has been written in the Cartesian coordinate system. That means the three numbers would be used, x, y, z, and let's take the vector quantity is y a y cap. Now I would like to ask from each one of you, mathematically once you will calculate its divergence, the divergence would be a zero or non-zero quantity. I want the input from each one of you over the live chat, and similarly once you will calculate its curl, the worth of its curl would be non-zero or zero vector. So if you are writing the answer, properly write divergence within the bracket 0 non-zero, and similarly curl within the bracket 0 non-zero. So at least I will get to know how far you are able to attach my basic concept of curl and divergence with the practical application. Anyways, physically I would like to draw this situation once again. So in Cartesian coordinate system we used to have 3 axes. So obviously I would be using those 3 axes once again. Here goes the x-axis. Yes, theoretically it might be looking over this 2D plane, but yes, it has been coming out from this plane. Now here goes the y-axis, and here goes the z-axis. Yes. Now the vector quantity which we had to draw over this Cartesian coordinate system is going to be y a y cap. What does that mean by the y a y cap? My dear friends, first I would be focusing over its magnitude. So anyways, the magnitude is simply going to be y. Yes, y, and you can precisely write mod of y. And if we'll talk about its direction, the direction is going to be either in plus a y cap or at minus a y cap, depending whether the analysis has been done towards the y greater than equals to of 0, or whether it has been done towards the y lesser than equals to of 0. Even for the better understanding, you can take an example. If y has been taken minus, you can feed y is equals to minus 2. So the minus 2y cap, what's the magnitude of it? The magnitude is simply 2, which is simply equals to of mod of y. And similarly, if we'll talk about its direction, the direction is going to be minus a y cap, obviously, which falls under the range of y lesser than equals to 0. Could you understand what I am saying? Now, one of the great thing is happening along with this vector quantity, that the strength of the vector quantity is dependent on y. As the value of y is increasing, maybe in negative sense or maybe in positive sense, the strength of the vector a vector is increasing. That's the first thing. Now, if you do the analysis towards the right hand side of the positive value of y, the direction would be in the direction of plus a y cap, and similarly towards the left hand side it would be at minus a y cap. So now the answer have started coming. The divergence non-zero, curl 0. Anyways, we'll try to see that. My dear friends, if I would like to draw the y a y cap precisely over the z axis, my dear friends, may I know what used to be the value of y over the z axis? My dear friends, over the z-axis, the value of y as well as x would be 0. Similarly, over the y-axis, the value of x as well as z would be 0. Similarly, over the x-axis, the value of y as well as z used to be 0. Why? You can see very well. If you have been placing yourself over the z-axis, that means neither you have gone towards right hand side, that means neither the value of y have become positive, neither you have gone towards left hand side, that means neither the value of y has become negative. Put together, the y has been 0, y has been 0. And once you keep y is equals to 0, by default the magnitude is simply 0. And once you have the magnitude is equals to 0, you need not to draw or you need not to have its direction. Why? Because the magnitude itself is 0. So simply the z-axis, which we call it y is equals to 0 axis, if we draw y a y cap, simply it would be sort of this. Yes, agreed. Each one of us should be able to understand now. Now, if you go at y is equals to of 1, y is equals to of 1, at y is equals to 1, so simply it becomes 1 a y cap, the magnitude is gonna be 1, that means you will be having an arrow with the chord length of 1 and the direction would be in the direction of plus a y cap. Plus a y cap. So it would be sort of this. And now they all would be having the same magnitude. Why? Because they all have been placed at the fixed value of y, that is y is equals to 1. Y is equals to 1. Yes, y is equals to 1. Now what I do, I would move forward with y is equals to 2. Y is equals to 2. I wanted to ask from each one of you, what about the direction? Direction would remain in the direction of plus a y cap or would it change? That's the first thing. And what about the magnitude? Magnitude would remain fixed at 1 or would it change? No. The direction would be in the direction of plus a y cap, whereas the magnitude would increase. Why? Because the magnitude is dependent on the y and the y has increased, the y has changed to 2. So may I know how the vector quantity would look like? The length would almost become double. The length would almost become double. Yes. Yes, no? Yes. And similarly, if you'll go at 3, it would become 3 times. Yes. The same calculation has to be made over the negative value of y. Let me take the reference of -1 and then we shall move over -2. May I know at y is equals to of minus, the magnitude is going to be 1. That means whatever the chord length we had, at least at this portions, the same chord length would be propagated over here, but the direction is just going to be opposite. The direction would be just going to be opposite. So the direction would be sort of this. Yes. And now once you'll move it to the y is equals to -2, the chord length would be doubled and the direction would be in the direction of minus a y cap. Yes, would be in the direction of minus a y cap. Now would like to ask from each one of you. If you have been standing anywhere over the 3D coordinate system for the time being, you have been placing yourself somewhere here. So may I know at this moment of point or exactly at this point whether the field is getting sourced or whether it's getting synced. What does it mean by the sync? That means the higher strength is coming in and the lower strength is coming out. Similarly, what about the sourcing? That means the lower strength is coming in and the higher strength is going out. May I know at this moment of point whether the sourcing or the sourciness of the field has been seen or whether the synciness of the field has been seen. I want the input from each one of you. My dear friends, you can see very well towards this dot, the less magnitude of the field have come in, whereas the high magnitude of field have emerged out. What does that mean of it? That means this point is the point where the field is getting sourced. Not only here also the field is getting sourced, here also field is getting sourced. Now if I would ask about this point, tell me whether the field is getting sourced or synced. The field is getting sourced or synced. I would like to ask from each one of you whether at this point the field is getting sourced or synced. My dear friends, again it's getting sourced. Why? You can see very well, if you'll talk about its direction, the direction is being towards minus a y cap. The lesser magnitude is going inside this point and higher magnitude is getting released out. That means again it is sourced. And that is why now, if you will calculate the divergence of the vector quantity a vector, which has been written as y a y cap, you will get to know the result is gonna be +1. What the plus indicates? The plus indicates the sourciness of the field. The field is sourciness. The field is sourcing. The field is sourcing. Yes. Could you understand? Could you understand what I exactly wanted to communicate? Probably my feeling may not be that expressive in English, but still the feeling must be understood to each of one. Then only you will understand the basic concept of the divergence. What the divergence do? The divergence calculates the sourciness or the sinkiness of the vector field, and you can see very well, at least over the y cap at anywhere over the 3D space, if you go and you observe how much amount of the magnitude have come in and how much amount of magnitude have gone out, you will see the amount of magnitude which have come in is lesser in strength, and the amount of field or the magnitude of the field which have gone out is higher in magnitude. What does that mean of it? That means outing is more than inning, put together it's sourcing. Agreed? Agreed what I am saying? Now the same case goes over this also. Now here the direction makes sense. You can see the lesser magnitude is going inside to this point, and similarly higher magnitude is leaving from this point. Put together again this point is sourcing. Now I would like to ask one thing from each one of you. What I am saying? I would like to ask one thing from each one of you. Can I apply the divergence over a scalar quantity? I want the answer in terms of yes or no. What I am saying? Whether the divergence can it be applied over a scalar quantity? Yes or no? Yes or no? Tell me. I want the answer from each one of you. Can the divergence be applied over the scalar quantity or not? Yes or no? No, it can't be applied. It can't be applied. Why? My dear friends, if you have been dealing with the scalar quantity, it would have only and only magnitude, but it won't have direction. That means you keep only and only its magnitude and you remove its direction. Now if I would ask one thing, at this point, whether the field have the nature as sourciness or sinkiness, you would not be able to say anything. Why? Because initially you were knowing the direction was inside for this point, and similarly this magnitude was leaving from this point, and put together you was able to calculate, yes sir, at this moment of point the magnitude which is coming in is having the lesser in magnitude, and similarly the vector quantity which is coming out has the magnitude higher than which is coming in. That is why you could calculate, yes sir, the field has the behavior of sourciness at this point, but once the direction has gone, no, you would not be able to say anything. If you go in this direction, it is sourcing, and if you go in this direction, it is sinking. Put together, the basic concept of the divergence, which deals with the sourciness or the sinkiness behavior of the vector quantity, itself is lost. Agreed? Could you understand what exactly I wanted to say? Now see what happens here, my dear friends. If you are from electrical electronics instrumentation, you just by heart the divergence cannot be applied over the scalar field. But did you notice sometime why the divergence cannot be applied over the scalar quantity? Because the divergence deals with the sourciness or the sinkiness of the field, and until and unless the direction is not been known, you would not be able to figure it out whether the sourciness has been taken place or the sinkiness has been taken place. Agreed? Understood what I am saying? So I would say one important line: the divergence over scalar field does not make any sense. Doesn't make any sense, and hence it's not been applied. Yes, let me ask one more important point, or let me ask one more important question. If you have been sitting somewhere here, would you be getting rotational force or not? If you will be getting the rotational force, what does that mean of it? That means at least at this point the curl is non-zero, and if you are not getting any of the rotational force, definitely curl is simply zero. So wanted to ask from each one of you, what do you expect At this point or anywhere over the 3D space, once you have the vector y, a y cap, what would be the worth of curl? What would be the worth of curl? Would it be 0 or would it be non-zero? I wanted to know from at least 2 or 3 people over the live chat. Over the live chat. What do you feel? At this point, the behavior of the vector would be irrotational, curl free, or would be rotational? Would be rotational. Wanted to know from each one of you. Wanted to know from each one of you. Akhil, Jen, thank you dear. Tell me. What would be the behavior of the vector at this moment of point? Would it be rotational or would it be irrotational? Would it be rotational or would it be irrotational? My dear friends, what's happening over here? You can see very well, as I have given an example, if you have been standing somewhere here, if two trains are moving in parallel in the same direction with the same speed, you will not get any of the rotational force which will force you to rotate on your own axis. You won't get. When you will get? When the two parallel trains are moving with the non-uniform speeds, like it is moving with a faster speed and it is moving with a slower speed, or if their directions are opposite. If their directions are opposite. Obviously, it is going to be irrotational. You can see the strength of the magnetic field and the strength of this field is very same. So put together, this point would not get any of the rotational field. And if you want, we can calculate with the help of mathematical formula of curl, the del cross y a y cap. How do we calculate this? Anyways, the curl is going to be a separate topic. Probably 2 hours or 3 hours we would be discussing about the curl itself. So you guys at least need not to have any doubt how to calculate the curl. That would be the exclusive topic together. So here is going to be ax cap, ay cap, az cap, dou of dou x, and here it goes 0 y 0. My dear friends, I don't understand how far you could understand, but just a minute. The y will never be differentiated with respect to the y. Why? Because the dou by dou y component exists just above than y. That means the y would be forcefully differentiated with respect to the x as well as with respect to the z, and the remaining component is simply 0. So once you will calculate the determinant, the resultant is going to be just a null vector. Just a null vector. Yes? Agreed? No? Could you understand? The things are moving in the very proper way. Neither you would be able to stuck over this point, neither you would be able to stuck over this point. Once you're thorough with the theoretical aspects as well as practical aspects, definitely end of the day you would be much thorough on the vector field. Yeah, anyways, we are learning so many good things, but I still wanted to know from each one of you. Should I go till this much depth of the vector calculus or not? If the answer is yes, just write yes over the live chat, and if answer is no, you can just write no. So I will try to skip this basics part, but yes, I would suggest to each one of you we should go with this much basic parts. Yes. Now, one of the best thing is going to come. Deliberately, I have changed my field a bit. Just a minute. So far, I have taken a constant field was getting multiplied with the ay cap. The second time, I have taken y ay cap. Now, third time, I would take z ay cap. Now, anyways, at very beginning, let me write the field which I would be taking. That's nothing but z ay cap. My dear friends, would you be able to draw this z ay cap over the Cartesian coordinate system? If yes, the answer is yes, try by yourself. And let me draw exclusively. Again, the Cartesian coordinate system requires the 3 axes in 3D space, which starts from x, y and z. X, y and z. Now if we'll talk about z a y cap, its magnitude is solely going to be decided by the factor of z. That means its magnitude or magnitude of a vector is simply going to be mod of z, because the magnitude can't be negative. That's the first thing. If you talk about the direction, in the direction of a vector, so I may call it a cap, that would be either plus a y cap if z is greater than equals to of 0, or minus a y cap if z is less than equals to 0. Z is less than equals to 0. Z is less than equals to 0. That means always the direction of the vector quantity would be in the direction of plus a y cap or minus a y cap, depending on the polarity of z. That's the first thing. And the magnitude is going to change as per the change in z. Yes, the y is not the factor which is going to decide your magnitude, because the magnitude is exclusively going to be decided by z. Now few of the very important thing is going to come. Let's see what. So now I would be taking the reference of z. So here goes z is equals to 0, here goes z is equals to 1, then 2, and keep on it increases in the positive direction. And similarly, once you go down or you comes down, it decreases or goes towards -1, -2, -3, -4, -4. Now let me do one thing. This is the axis which we call it y-axis, towards this positive, towards this negative. But as we have been talking in the last question, in y-axis the value of x as well as z would be 0. If the value of z is 0 over the y-axis, definitely the magnitude gets 0. Put together, the magnitude is simply going to be 0. The magnitude is simply going to be 0. Yes, agreed. Now at 1, keep in mind at 1, which one it is? It's positive 1, and when the z is greater than 0, put together the direction of a vector would be in the direction of positive a y cap. What about the magnitude? The magnitude would be 1. As I would be moving towards the right side or left side, would the magnitude would change? No, my dear friends, the magnitude would not change, because the magnitude is exclusively getting decided by the z, and here at least on this label the value of z is fixed at 1. Z is fixed at 1. Yes, and at 2 the magnitude would just get doubled, and at 3 it would get tripled. And at -1 the direction would be just reversed. No, the direction would be just reversed. Still the chord length has to be very same as I have used over z is equals to +1, but yes, the direction would be reversed. And here it would be -2. Yes, here it would be -3. Now wanted to ask from each one of you, what about the divergence at any point over the 3D space? Would it be 0? Would it be non-zero? Would it be positive? Would it be negative? Yes. I wanted to know from each one of you. Many of us know how to calculate the divergence of any vector field with the help of mathematical calculation. But I would suggest to each one of you, keep aside the mathematical calculation for the time being and just focus over this practical understanding. Tell me, at this moment of point, 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 or randomly anywhere over the 3D space, the divergence of the given vector field, would it be 0? Would it be non-zero? Would it be 0 or non-zero? Tell me. I want the answer from each one of you. At this moment of point, what about the worth of divergence? Whether it's 0, whether it's non-zero. My dear friends, if you come across this point, no, the amount or the magnitude which have come in is 1, and the amount of magnitude which has been left out is again 1. 1 minus 1 simply becomes 0. Now if you have come to the plane of z is equals to 2, the worth of magnitude which is coming in is 2, and the worth of the magnitude which is leaving out is again 2. What does that mean? That's again 0. And similarly, if you come down to -2, although the direction is now reversed, but still the worth of the magnitude which is coming into this point is 2, and the worth of the magnitude which is leaving from this point is 2. What does that mean of it? That means ZAY cap, if you will calculate its divergence throughout the range of 3D space, it would always be 0. Throughout the 3D space, it would always be 0. If you want, you can calculate the divergence of A, which used to be dou of dou x, the component of A vector in the direction of AX cap, which is simply 0, plus of dou y, the component of A vector in the direction of y, which is z over here, and similarly, dou z, the component of A vector in the direction of z, that means the multiplier of AZ cap, which is again 0. Yes. Yes, no? Whether you are able to understand. Now the next thing comes in the picture, my dear friends. Tell me, what about the curl? What about the curl? Now, if I come across any of the point, whether I would be experiencing the rotational force or not, any of the point. If I come across any of the point, let's take this point itself. Would I be facing the rotational force or not? If I would be facing the rotational force, definitely the curl of ZAY cap would not be 0. Nobody should use the curl formula for calculating the curl of ZAY cap. Each one of us should just focus over the practical understanding of this field. Try to place yourself on this point and try to experience this rotational force, whether you are experiencing any rotational force or not. Tell me, you are experiencing any rotational force or not? Yes or no? I wanted to know from each one of you. My dear friends, the same example which I have given, you have been placed somewhere here. Now you have got the two train tracks. This is the first train track, this is the second train track. You can see very well the speed of train track or the speed on this track is higher because the magnitude is higher in this side, and similarly the speed of train is bit slower in this track. So definitely you would be facing a rotational force over this point. You would be facing a rotational force over this point. I would like to ask from each one of you that rotational force would be clockwise or would be anti-clockwise. Again, I am saying you had to place yourself over this point, then only you would be able to understand whether the rotational force which was experienced because of the ZAY cap, whether it is clockwise or anti-clockwise. Tell me, clockwise or anti-clockwise? If you really wants to know the exact fundamental of the rotational or irrotational vector, you should come through this, clockwise. The first answer have come clockwise. Saurav Bhandari have said clockwise. Obviously, my dear friends, clockwise. Yes, clockwise. But, how the clockwise would be addressed? How the clockwise would be addressed? What I do, I use my right hand. I would place my curl towards the direction of rotation. I place my curl or I place my four fingers towards the direction of movement, and the thumb shows the perpendicular over the curl. That means if you have taken this as positive y axis, this as positive z axis, this as positive x axis, the perpendicular over the curl is in the direction of where? Minus ax cap. Is in the direction of minus ax cap, because once you will calculate its curl, no, the curl would not give the direction of this clockwise or anti-clockwise. What is going to do? It will take its right hand. The right hand would be placed in the direction of rotational field. The thumb would show the direction of the curl of this given vector. So once you will calculate the curl of ZAY cap, may I know which factor would come out? Obviously, it has to be a vector quantity. Which factor would come out? You can see very well, sir, the thumb is placed towards direction of minus ax cap. That means obviously only one factor would come out, and that is nothing but ax cap. Would it be positive or would it be negative? Definitely it has to be negative. If you want, you can do that now. Yes. The curl simply ax cap, ay cap, az cap, dou of dou x. And here it goes 0, z, 0. Yes, 0, z, 0. What's going to be the worth of ax cap? Ax cap, dou of dou y of 0, that's the 0, minus of dou z, that's minus 1. And the rest of the component is simply 0. And you can see very well it is been minus of ax cap. It is been minus of ax cap. Could you understand what does it mean of it? What does it mean by the ax cap? What does it mean by ax cap? That is what I am saying here. My English is not that good, but still I would try to communicate to best of my knowledge. My dear friends, the curl was taking place with this plane. Which plane it was? You can see very well which plane it was. It was a yz plane. Now, if you draw the normal over here, no, the normal can come towards outside, that's the plus Ax cap. When that normal would be used? That normal would be used when the rotation has been taken place in the anti-clockwise direction, and now the thumb would be placed towards the plus Ax cap. Plus Ax cap. Now similarly here what is happening, the rotation has been taken place in the clockwise direction in this direction. Now you would be placing your curl or the palm of your right hand, you will get to know the thumb has been placed towards negative value of Ax cap, negative value of Ax cap, and that is why minus Ax cap have come into minus Ax cap have come into. Now, anyways, I am not going to summarize the each and individual concepts, at least in today's video, because as I have said, I would be giving the plenty amount of explanations, I would be giving the plenty amount of practical exposures just to understand the basic crux of the vector calculus, and the same thing I would be doing over the random variable as well as random process. May I know when the divergence becomes non-zero? My dear friend, the divergence becomes non-zero when the Ay cap comes along with y, or maybe Ax cap comes along with x, or maybe Az cap comes along z. Why? Because if y comes along with the Ay cap, what would happen? In the direction the vector field is traveling in the same direction, either the magnitude is increasing or decreasing depending on the value of y. If the y is in numerator side, the magnitude is increasing, and if it comes towards the denominator side, the y would be decreasing. And as in the direction the magnitude is increasing or decreasing, definitely there would come the concept of divergence. Yes, you can see very well, it is been moving towards this side, and in the same direction there would be the reduction as well as the increment of the magnitude. And if there is a reduction or the increment of the magnitude in the same direction where the wave has been traveling, what would be the result? The result would be either it would be converging, either it would be diverging, either it would be sourcing, either it would be sinking. But this factor won't lead curl. This factor won't lead any rotational force. You can see by yourself, and that is what is happening. My dear friend, if the x come just below the dou by dou x, if y comes just below the dou by dou y, if z comes just below the dou of dou z, the value would always be 0, because if this is a function of z alone, in future never ever it is going to be differentiated with respect to the dou z, it's just going to be differentiated with respect to the x as well as y, the value has to be 0. What does it mean of it? If you have the factor like y ay cap, z az cap, x ax cap, those all factors would be favorable conditions for sourciness or sinkiness, but yes, they would not go for any rotation. Whereas if you have been dealing with the Ax cap, anything apart from x, it could be y, it could be z, the function of y and z, they would be responsible for rotation. You can see by yourself. Why? Because in future, if you have the function of y and z below the dou of dou x, definitely they are going to be differentiated with respect to the y as well as z, and probably they would lead non-zero value. And you can see by yourself the z ay cap, what it says, the change in magnitude would be in the different coordinate system in compare with the direction of the vector itself. You can see very well, the direction of the vector was always towards ay cap, whereas the magnitude was not changing in the direction. The magnitude was changing towards upwards as well as towards the downside, and that's the factor which would introduce the factor of curl. Anyways, I wanted to have few number of feedbacks. What about my English? Whether I am able to communicate my thought process into the proper way or not? That's the first thing. I want the input from each one of you. Otherwise, I'll improve upon specifically at that portion. And what about the level of lectures which we have experienced exclusively in today's class? Because I know many of us do not exactly know about the divergence, curl and gradient. Tomorrow also I would be discussing about the divergence, curl and gradient by taking few difficult or complex vector calculus. Anyways, before ending today's session, I would like to take the input from each one of you, whether I am able to visualize the concept in the proper way or not. That's the first thing. Secondly, how far you would able to understand this basic concept, this basic concept. Anyways, do not delay. If any sort of doubt you guys are having, you can put it over the live chat. Otherwise, we will end our session because daily I have marked for the 1 hour only, 9 to 10, 9 to 10. See what happens. I have been the person from the northern part of the India, no? So what the problem we have? Repeatedly or repeatedly we do not speak in English. That's the problem we face. Otherwise, when I was there in BRC, the 5 years, I talked in English alone with my bosses, with my colleagues, with my juniors. So what happens? If I would be taking the classes in GATE Academy Global continuously, repeatedly, definitely, I would come in my pace. And end of the day, each and everything would be proper communicated. Okay? Okay then, bye-bye. Take care. We'll meet precisely at 9 p.m. tomorrow. Till then, bye-bye. Take care.